By the way, why is this thing not just a squared plus b squared? Why is a plus b all squared, not just a squared plus b squared? Can anybody prove it to me? What do we reckon? I mean, clearly it's not right, because this is what you've been told all of your mathematical lives, like it has to have that 2ab in the middle. But my question is why? I mean, you can think about it like this, can't you? So a plus b all squared is just a plus b times itself, okay? So how do I know that that thing must be equal to that and not equal to that? Because if you didn't know anything about multiplication, you could say, a times a makes a squared, and b times b makes b squared, like one thing from each bracket. So why do we have to have this 2ab term in the middle? So where does that come from? Okay, so I think what you're getting at there is the distributive law. So you're basically saying everything in the first bracket has to meet up with everything in the second bracket. So the a has to meet up with that, and the b has to meet up with that. But that still doesn't answer my question. Why? Like, why could I not just do a times a and b times b? Why do I have to make sure that everything meets up? Why should that thing be equal to that thing? Think about it like this. Why do we say squared and not to the power of 2? It's got something to do with a square. So if I draw a square out, so by definition, a square has all sides of equal length. You happy with that? Okay. In fact, if I'm looking at a plus b squared, what are the lengths of these sides? It's a plus b, right? So this is a plus b, and this must also be a plus b. Are you happy? Now, what property of the square am I looking at if I do the operation of squaring something? So what property of this square am I looking at if I'm squaring something?
Just square.
If I give you another example, so I draw another square, okay, and this square has side lengths of 5, what property of this square would 5 squared correspond to? The area, right? I heard it. Okay. So the operation of squaring something looks at the area of the square. Looks at the area of the square. So you're happy? I'm taking a square with side length a plus b, okay, and I'm finding the area of this. Well, have a think. Like, this side length here is a plus b. In other words, it's some part plus another part. So why not just break it up into its two respective parts? So let's call that a and that b, okay? And likewise, and I'm just going to write it around the other way so it makes sense. Okay, so this is still a plus b. Likewise, I'm also going to break this up into a plus b. You happy with that? Break it up. There you go. So you got the 4 parts there. That part there is just a times a. It's just a squared, that little square there. Okay? That bit down there is just b times b. It's just b squared. Be happy you've got 2 more parts there. Got 2 more parts. And each one of those parts is going to be a times b, because that's a times b as well. A times b. Okay? So you're happy you have to have that 2ab in the middle because you get these parts. Like, clearly, a plus b all squared, that area of that square is not just that bit plus that bit. You've also got those bits there as well. Okay? Now, that's kind of a little sort of side point I wanted to make, because a lot of the time I realise in maths, and perhaps you've probably experienced this yourself, you probably just learnt the rules without really thinking why. Okay? So something as simple as this, a plus b all squared, you know it's equal to that. You've expanded that out enough times to know it's equal to that. But I wonder how many of you have actually thought why that makes sense. Okay?